That sounds horrible. I hope there's no audio on this thing. You're also in a spacey shut in the middle. Yeah, you can pull. I'm good at it.
Which side box are ready? Go for it.
3 pulls left. Huh? I believe in you. Yeah, let's go for it. I'm gonna kick this place. Here comes Anton. That red mark coming to this red mark, you're either going to be 20 mils this way or 20 mils this way. But I'm saying there's also marks the other way. But those marks are also fat. I'm looking for a sharp line.
There's nails.
Oei. I'm just going to check this side.
Yeah, so all you basically need to do is just pour a lane over.
Yeah.
And then you can check the inside of the barrier. Do the same on that side, you know?
Yeah. Now can you send me someone with a straight piece of timber and a concrete nails, 2 please? No glove.
Is it?
Ja, dit blokje.
Okay.
De hele organisatie.
Niet van Dit was zo.
Moeder is net al van zo.
Zeg maar weer. Ja. Ik heb aan. is een stukje asfalt daar.
The problem is we need.
Je rijdt 2x3 door dan verder.
You guys must check that. Are you going to do the same for where you're going to nail in a piece of 2x3 so that when that mark hits there?
Again?
You're going to also do the same that side, put a 2x3 going across here.
No, so we're going to just transfer this liner.
Yeah. You're going to put a 2x3 across.
Yeah.
I'm going to take a piece of 2x3 and nail it here to the asphalt.
Okay, I haven't measured that side yet.
Idiot and idiot.
Wil je dan weer terug op?
Need an update. How long?
No pass maker.
Round about a meter.
Got a distance of 21.953. Total movement northwards is 15.712. Got a 0 creep. And then we've got 1.053 in.
Grant. Grant. I want a lekker song to play and the mic.
Two miles is not going to make a difference.
Yeah.
I'll push my white line a bit thicker. Don't worry. 2 miles is not going to make a difference.
What is the cover from on the screen?
got concrete nail. Normal nail.
Right then, babe.
Yeah.
Your side is now your ruler and this thing shows in the middle, so you have to move it a little bit.
Yeah,
man,
we're going
move
to
it.
the edge.
No, man, move it.
I need it. But I need that mark to hit here. What type of nail is that?
The old one.
The very old one.
Very old one.
So right, go for it.
Then it broke easy.
You did a density check on this.
The wireless. Yeah, it's 60L.
How's that?
Like I can literally, when I stop.
Wat op je stand? Ja, ja. Ja, sorry man, ik moet gou vinnig die audio uitsorteer hier so vir as hulle daar kom.
How much are you, Anton? Surveyors will pass it. No, that's 10, that's MPA. What song did you go for? Or did you leave it in his hands?
I think he's very capable of that.
Go for me. What do you need? Sorry, for some reason my radio wasn't working.
Really national anthem.
2, 1, 2. Mic check, 1, 2. Mic check, 1, 2. Mic check, 1, 2, 1, 2. Mic check, 1, 2.
Good afternoon to everyone. Just to let everyone know that we've got 565 mils left to go until the launch is done. Hallelujah. We're going to pull 200 because of our stroke is limited to 500 mils. So we're going to pull 200 and then we'll do the last 365 in one last move, hopefully. Thank you.
It goes like
What do you want me to do? Let's wind up. What did you get? 357. But they got 350 on that side. That's perfect.
Alright, ladies and gentlemen, we've got 350 mils left to go. I'll let you guys know as soon as we start pulling. I'd really appreciate if we can get an applause as we're going, because I think it's going to happen in a couple of seconds. Thank you.
Meneer, ga die in die af.
Wrapped around your soul with no control. You can't breathe when you're drowning underwater. There's so much water. I'll run, I'll hide. Darkness always clouds my mind. Now look behind. It's moving closer every time.
Hij was op John.
I can't pretend that I have a strong defense. There's darkness, my old friend. Won't get me at the end. Wrapped around your soul.
Come on guys, we're pulling the last 350, let's make a noise! This isn't holding in anymore.
I'm holding this. We're on 240. You can give the measurements. But I need to hold it.
340.
No, man.
200 mil.
We're also on 200. We're going to cross the 170 mark now.
Oh, you want Peter to check the pad? It's just the pad that's moving out slightly.
Watch it carefully, please.
Let's just come on, 125. Let them know, 125. Come on, baby. 100 mils. Come on.
Count it out, listen hard. Come on, guys.
To pick up where Jalal left us off with is we have spoken about the jacking frame installation, so now we are at the jacks. This is the big boy, this is the one pulling the bridge, 330 ton jack. He's working with 31 PT strand cables, so this is the big boy that will overcome the whole friction of this bridge, and this is the one that will pull. So he's connected onto the main jacking frame, the type 1 jacking frame, and his actual stroke length is 550 mm, but we are stroking the bridge about on 450 millimeters, and then we're gonna reverse every time there's a piston, and we just pull every time 450 mils until we get to about 23 meters at the end. Okay, looking at the wedges that are actually grabbing onto the strands while we are pulling, we've got 31 wedges here that are grabbing each time that we pull the stroke. The wedges grabs onto the cable, and while the piston goes out, that's the mechanism is clamping onto the cable, and it just pulls along. And as soon as you want to release, then the cable, so then you can't get slack into the cable, then you come to the back, then you see the wedges here at the back will then activate, and will keep the cable just this whole time under tension, so that it doesn't get no actual slack. So when you're going for your next stroke, the tension is already in the cable. Okay, so this is the 50 mm diameter bar that we are using with our 120 ton jack. So if we need to activate this, if there's a friction is too high and the big jack can't handle the actual friction, then we will activate the 120 ton jack and we will pull with a 50mm diameter bar, which will connect onto our deck pulling brackets that are underneath the deck. So over here we've got our laser bracket where our infrared laser gets connected. So it shoots to a target and this target gets transferred to our control room, and over there we can see exactly how far we are pulling each side, and we need to be within 50 millimeters. So this is our target, and that's how we see how we stay within our tolerance. So over here we've got our 31 strand post tensioning cables. We are pulling these to about 40% of their ultimate tensile strength, and they are about, so we are pulling a total length of 23 centimeters. So the total cable length at this moment we've got in about 35 meters of them. Okay, so looking at our monitoring systems, so this is our first one. This is a guide telling us when our bridge is moving out of alignment. If we see that we are out by 15 millimeters, we should actually start to activate our side guides, and the side guides we should just put in packers and it will steer the bridge back into its position. So looking at another monitoring system, we've got a 50mm bar that is connected between the two bearings. We've got a leading bearing and a trailing bearing, and we've got a glass tail here. So if the bearings are not pulling at the same speed, and then this bar will get activated, and this piece of glass will accidentally crack, and then we will see that the two bearings are not pulling at the same pace. So we are now on the trailing side of the bridge of the jacking. It's exactly the same setup. We've got a 330 ton jack, 31 strand cables, and this is if we need to pull the bridge back, and it's also getting activated while we are pulling at the leading side. It is also keeping the bridge just into place so that the bridge doesn't move out of line.
So you see here on the top row, you see the distance changing, and down here we have the pressures, and number 1 and number 3 are the retaining jacks, while number 2 and number 4 are the pulling jacks. That's why the pressure is slightly different. So as we are moving, you can see the distance changing here, and there is a visualization from the left to the right, just to make it easy for the operator to see that we are moving both sides at the same speed. And also on the pressures, in the center we have the nominal pressure we want to achieve. And on that control desk we are operating the pumps, and here we see on the right hand side the status of the jack anchorage, whether they are open or closed depending on what we are doing. Now we have about half stroke. If one side is moving a bit faster, then we just switch that one off, and then we can do the correction as we move.
Hi, good day. My name is Heidi, and I've been working on this project since 2015. I've learned about different people with different backgrounds and different expertise. I just want to say thank you to all the construction team for all their hard work and all their practice.
Good day, everyone. My name is Nesipo Kayempi. I was born and bred in Ashton. I'm working for H&I company, And working for such a huge company has been very exciting because I've learned a lot from the past year that I've started working here as their admin clerk. And while working for this company, I managed to overcome my introvertism, and now I can handle any challenge that is coming through my way. Thank you very much.
My name is Siyabonga Ngomonye. I'm staying at Zolane. I'm representing HNI as a community liaison officer, and also representing the 4 wards, of which it consists of Ward 12, Ward 10, Ward 7, and Ward 9. To work in this project has been it's not easy to be in this position of mine. I started to work in this project since 2015, October, until with the previous company called Basil Reed. Now, then I get appointed by HNI again when they took over to the project in 2019. So since then, I was working with this company. It's good to work with this company because I experience how to deal with the different cultures, with different people, and to know their problems.
Hi, my name is Rodney. I'm a structural engineer from AECOM. I'm going to talk to you about arches and basically how the forces are flowing in the structure. So usually arches are chosen because of they don't hide the landscape. As you can see, it's a nice and open structure. We usually use them for spans between 80 and 170 meters. This is 113 meters, so it's within that. That's when it becomes competitive in terms of cost. Yeah, just to talk you through how the forces work. Most people actually think when the traffic comes onto the bridge that most of your bending will be at the middle. But it actually doesn't work like that. When the traffic gets onto the bridge, the bending happens between the 2 arches. So it's bending transversely. That's where most of your bending is. Now those forces, once the deck starts to bend between the 2 arches, the beam transfers the force to the cables, and the cables transfer the force to the arch. And that's what is holding up the bridge. So if you think about it this way, in terms of forces, an arch is in compression. It's basically like 2 table legs trying to kick out at the edges. So when they feel the force, it's trying to push out at the abutments. Then to stop that, we connect the 2 ends of the arches together with that long beam. And that beam keeps the arch feet together. We put in cables in the beam and pre-stress it to keep it in compression at all times, so that it can resist the arch kicking out. So also a good thing about those cables in this beam is it keeps the whole bridge compressed, and you never have any cracks on the beam, so it leads to also low maintenance in the long run. The most difficult aspect about this structure is actually optimizing your forces in the cables, because you have to tension them for them to transfer the load from the beam to the arch. Now, the tensioning process has to be over a series of steps, because if you tension one cable, you slacken the one next to it. So it's like a game of cat and mouse. Once I tension this one, the next one becomes loose. I tension the other one, this one becomes loose. So all of them have different forces in them. You have to do it over a few runs until you get your optimum forces in the arch. Thanks.
Good afternoon. As you can see, we installed 4 threaded bars in the center of the frame. That's basically to get the frame into position, checked by the surveyor, lining it up with the top hole of the frame to the top center hole of the sliding bearing. And this is basically to pull the bridge back if any jam is happening while the launch is being done. So we pull it back with the Type 2 jack and to fix any problem happening or to see where the issues are lying.
At this stage, I'm currently busy with the installation of the sliding bearing into its final position under the tie beam. Access control and access scaffold is here because of access restriction and house limitation because of our loading or lifting equipment. From here on, as we see where the bearing is standing, from here we're going to slid it into its final position into the tie beam. I'm currently busy with the casting of the concrete into the sliding bearing. I use a 40 MPa 90mm stone. The steel element is the sliding bearing which is coming from Nova. Underneath this sliding bearing we got a stainless steel plate that's running right through. It's a true surface and it's resting on Eberspacher pad that's coming from Germany, which we grease beforehand. After that we're gonna put some more Eberspacher pads in front of it so we can slide it in, and we use a towel to slide it into its final position.
Right, this is Brahma Peach, engineer and surveyor from the consultant side, and I'm Wayne Phillips, surveyor from the contractor side, and both of us, we basically controlling the setting out to precise millimeters of the structure over here. And currently what we're busy doing, we've got 7 targets placed on the east abutment, as well on the west, and 1 on the cantilever over here. So we're monitoring the total shift as well as settlement and confirming with the guys on ground level what distances they get. So basically our machines are telling us that info.
Tell us net waarna jy kyk.
Okay, eerst het ons geel taakjes wat ons monitor om te kyk wat is die verskywing in state value, en dan monitor ons ook die offset van die brug vanaf centerlyn, as ook ons hoogte om te kyk wat gebeur met die dek van die brug. So ja, dit is A, X en Z waarvan ons praat, en ja, en ons is die manne wat ons sorg dat ons hier binne 'n toleransie van 1 millimeter, en as daar enige versakking is, moet ons net dadelik laat weet vir die man om te sê daar's 'n probleem.